Today we're going to talk about a one-to-one function. And its name, one-to-one, really implies that one x value is going to match up with one y value. One y value is going to match up with one x value. And that's the gist. Notes over. Good luck on your homework. Sweet. Just kidding. Let's do some. Here we go. We're going to take these two functions, and they told us what they are up here. And we're going to use this domain for both our f of x and our g of x, okay? And so we're going to use mapping arrows. Let me explain what that means. So this left side has us using f of x equals 2x. So we're going to do 2 times negative 2, we're going to do 2 times 0, and we're going to do 2 times 2. And we need to know what those answers are. So negative 4, 0, and 4. And what we would officially do is draw an arrow over to each of those values. But that gets a little muddled. You don't normally write the math in there, okay? You just write the answers, correct. So I'm going to write just the answers here. I'm going to do my work off to the side. So this one is going to be an actual good mapping, so to speak. So our g of x is equal to x squared. So I need to know what negative 2 squared is, 0 squared, and 2 squared. So again, in the range bubble, we just put, oh, look at that. I didn't have to write the 4 twice. Okay, so in our mapping, we're just drawing the arrows. Will you please look at what I did? Because I'd like you to change your notes so it's reflective of that. Okay? So we have a little bit of a difference between these two functions. And it's pretty clear to see, once we draw our mapping arrows, where we have a little bit of a problem. So what's the difference between these two functions in regard to the mapping for the range?
The domain of g isn't x to x, no, y to y, whatever it is. 1 to 1. 1 to 1, yeah, 1 to 1.
All right, great. Domain of g does not have a one-to-one mapping to the range because of that double dipper of 4. Because we have 2 arrows that map to 4. So it's not a one-to-one. Oops, I don't want that. So g of x is not 1 to 1.
So if it was like every line?
Correct. If it was 1 to 1, then each domain value would map to just one range value, like it did in f of x. Good. Well, that's pretty much the basic gist. Now let's practice some. Let's take a look. All right, down here below our box, 1 of the 4 table below represents a relationship where y is a one-to-one function of x. A one-to-one function of x. Which one is it and why?
Those and the y, they all are different.
Okay? So if I look at number 1, do I have repeaters of any kind? I have repeaters there, so that is not 1 to 1. That's my shortcut. I didn't include it up above because I don't want it to look like a letter H. But this is 1 to 1.
1 to 1.
Can't you just do 2 dots?
Sure, yeah. In number 2, do we have any repeaters?
Yeah.
Correct, we do. So this is not 1 to 1. In number 3, do we have any repeaters?
No.
No, so that's a good one.
Yeah, but how do you know if it goes further if there's going to be?
Well, just on this little chunk of block.
We'll use what we know, just like any good scientist or mathematician. In number 4, do we have any repeaters?
Yes.
We have a couple, don't we?
And
Wait, so if the X repeats, yeah,
Yep. No repeaters allowed.
Repeaters will be punished.
That's right. Repeat offenders will be ignored. To the back. We can also look at a graph in terms of one-to-oneness using either what we know from our previous math experience, a vertical line test. Anybody recall that? Can somebody explain it to me?
Is it a vertical line goes through dots?
Yep, if we pass a vertical line through our graph, and if you can imagine that sliding left and right. I knew it. If you can imagine it sliding left and right, if it only hits one time, then we're good to go. So here's a vertical line,
So,
and if we slide that left and right,
so it'd be like 4.
so that's a fail for a vertical line. This is a pass. How about graph number 3, the circle? Is that a fail or a pass? It's a failure. Good. And number 4, that's a pass. Okay, so far we have 2 that pass. The parabola, number 1, and the line, number 4. Well, what we're going to do though, all right, so circle the 2 graphs above that fail, or that pass. Great. One of these is one-to-one and the other one isn't. And what we'll use is something called a horizontal line test, Okay.
graph 4 is 1-to-1.
okay, to determine if it's a one-to-one. So horizontal lines go across, and again, we're going to see about if it hits 2 times or more, then it fails.
Pass.
I believe you are correct. This one is a passer.
Sweet.
So, our linear equation, the graph of the line, passes both the vertical and horizontal, so it is, drum roll please, 1, 2, 1. Da, 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 da. Okay? Quick timeout. This one is still a function. Well, what we're going to learn is it will not have an inverse. We're going to learn that tomorrow. Okay, but it is still a function. It's just not one-to-one.
I get it.
Okay? Good.
So that means number 4 should be a one-to-one function.
Are you on exercise 4?
Yeah. The exercise 4, number 4.
No.
4, 4. This, the parabola,
Yeah.
is not one-to-one.
I mean,
Remember,
I'm not in on that.
it's got to pass the vertical and the horizontal to be one-to-one. So I'm sorry, you lose.
I'm not 3.
Okay?
3 doesn't work either.
All right, let's see. Here we go. Whoops. Oh, see what happens when you put things in the wrong places?
Oh, wait.
All right. Oh, yeah. Binga bonga, then bunga bunga. Try it again. Vertical. Fail. Vertical. Pass. Vertical.
Thank you.
Bless you. Pass.
I thought that vertical was moving like back and forth. Is it just anywhere on the line?
Anywhere, and I can move it anywhere. So like, if my vertical line was right on that x-intercept, then it would pass right there, but it fails everywhere else. So it's a failure.
And number 2 is pass?
Number 2 is pass. Anywhere I go, I hate it when it does that. Anywhere I go, I'm only hitting 1 point.
Oh, it never like collides with 2 spots?
2 spots on the graph. That's a bad thing.
Like, alright, so, you know.
That's
if
bad.
It's right here and right here, then
That's
it's bad. but
fail.
Only, okay.
Yep, correct. All right, horizontal. That's a pass. Oh,
Fail.
major fail in some places. This is a pass, and then this is a fail. So, our one-to-one is only choice 3.
Well, what happens if it goes under and you can't reach it?
Then no.
See, look, it's not gonna hit it if you go
What's
too
that
low.
say?
I don't know what you're talking about.
Okay, for number 3, if you pull the line down into the negative, it
Which-
doesn't hit it.
Which line?
3.
Red or blue?
Right.
Red line.
It doesn't matter, cause either way.
Right. That can move.
Yeah, but what if it
Oh my
doesn't
gosh, I
hit
love how they all move.
It's okay for the areas that, because there's no graph down here, so it doesn't matter what happens below. It's irrelevant. Number 5. The distance that a number x lies from the number 5 on one-dimensional number line is given by the function here. Beautiful. Show by example that d of x is not a one-to-one function. Okay, algebra students, you with me?
No,
Great, I love it.
I didn't take that class.
This is a what function? D of x is a what kind of function? What's its name? Linear, quadratic, absolute value, exponential? What kind of function is that?
That one.
Absolute value. I'm absolutely certain that you didn't remember. Absolute value function.
Well, if I would've saw the little line sticking up and down, I would've known it was absolute.
I mean those little lines right there?
Yeah.
So it's gonna be.
That are printed on the worksheet that you have in front
Well,
of
I
you.
was looking at what you were writing down.
Okay, go ahead. It is. It's going to be a V-shaped, beautiful function. Let me jump to my calculator real quick and see what this is actually going to look like. Math abs. Remember how to get there?
No.
Easiest way to get abs ever. Math. Slide over to num, and the very first thing is abs. All right, I'm going to go just look at my table, and my table is gross, so I'm going to fix my table. And let me look at my table now. That's less gross. Beautiful. And I'm noticing something that I call symmetry. You see the symmetry in the range? Good. So I have 3s, and I have 2s, and I have 1s.
Yeah, a 0.
Okay, that's what I'm calling symmetry. Okay? Can you plot those points roughly on your sketch? Here they are in a larger version, for those of you who can't see them. Will you plot those points on that rough little sketch of graph paper there that you created? Please and thank you. Thank you very much. Whoops, that's
Wait, so
Did you get absolute value again?
Go to math. Slide over to or num. The very first thing is abs. And then you put in the x minus 5, whatever's inside of the absolute value sign.
Or just couldn't find the.
Should look something about like that, roughly. So is this, or how can we show this is not a one-to-one function?
You do the horizontal test.
Horizontal and vertical, you gotta do them both. So vertical line, does that pass?
Yes.
That's a passer. Horizontal line is a fail. So it's not one-to-one. The other option you have is to show that table of values from your handy-dandy calculator. Let me write that, D of
But
X.
do we have to do both? or just
No,
one?
no, you can do one or the other. Some of you like one better than the other. So I know that at 5 it was 0, 4, 3, 6, 7, so 5, take away 5, 4, take away 5, and because we have repeaters, we are not, that's the fail, the horizontal. Okay, so we have functions. We can look at their graphs and check out horizontal and vertical. We can look at their table of values, and we want to get rid of repeaters. We can, that's it. That's all we have to do, okay? Graphs or table of values. Devin?
I have a question on that.
Okay.